Hi everybody, back again. Today lecture will be about mesh current analysis. Let me refresh your memory. Last time we explained node voltage analysis and the objective was to calculate the voltage at each node. What did we use? We used two laws. We used Kirchhoff current law and we used Ohm's law. Here in mesh current analysis, we'll try to find the current in each mesh. And you observe that we have voltage source. What we are going to use? We are going to use Kirchhoff voltage law instead of Kirchhoff current law and Ohm's law. So Ohm's law always with us. But the only difference between the last method and this method, the node voltage method, we used Kirchhoff current law. In this method, mesh loop method, we are using Kirchhoff voltage law. Remind you, Kirchhoff voltage law, the sum of the voltage in any mesh is equal to 0. So let's go. Okay, that's this example. We want to find the mesh current I1 and I2. We have only two. Okay, so what we're supposed to do, we just, let me remind you, we always choose mesh current in clockwise direction, always. Okay, so that's a rule in clockwise direction. We'll now start to write Kirchhoff voltage law for each mesh. For mesh 1, that's the mesh 1. Okay, if I1 going in this direction, it means I1 going here. So 15 voltage. Okay, it's not clear, right? Let me make it 15 voltage, and that's plus. When the current I1, this is I1 by the way. So I1, it means here I1, I1, I1 in this all direction. Let me focus on this one that's going through 5 ohm. So it will make plus or minus here. So the plus here of this voltage source connect the plus will be minus. Minus the voltage across 5 ohm, which will be equal to 5 times I1. Okay, you go there and the current will be flowing in this direction. But very important now, take care. That's 10 ohm. And you got current in this direction I1 and current in the other direction I2. So if you are saying that the current in this direction, why I'm saying this direction? Because when you work in the first mesh, the direction all in this clockwise direction. But it happened that the 10 ohm, it's a common resistance between mesh 1 and mesh 2. So we are going to say that the current in this direction now it's equal to I1 minus I2 because I1 going in this direction and I2 going in the opposite direction. So if you are going to say that the current in this direction, it will be I1 minus I2 when you're saying it's flowing in this direction. So it will make voltage drop plus and minus here. So what you're going to see minus or plus here, let's look at our reference voltage. 15 volts, this is a positive, and the positive connect to the positive be minus. Minus what? 10 ohm, and the current I1 minus I2. Okay, we're going to find another voltage source, 10 voltage, and the positive is here. Again, the positive connect to the positive be minus 10 volt. It will be equal 0. Okay, let's simplify this equation. So we have 15 minus 5i1 minus 10i1 plus 10i2 minus 10 is equal 0. Collect the terms of i1 minus 5 minus 10 will be minus 15 i1 and i2. You got 10 I2 only plus 10 I2. The constant number 15 minus 10 b plus 5 is equal 0. So minus 15 I1, make it plus here, minus 10 I2, okay, minus 5 equals 0. Move minus 5 to the other side of the equation will be 5. So that will be your first equation. Okay. Now we want to try it for the mesh 2. Okay. For mesh 2, you start from here. That's your reference, 10 voltage. You write 10 positive, and then when you move in this direction, the current will be in this direction. To make it now, just please, I am on the site. I am working on the site. Let me use the marker to make it clear for you. See, I'm working here now. I'm done the first time with this side. Now I'm working in loop 2. Why I'm doing that? Because you got to know the direction of the current in this one. Okay, so that's that's 10 voltage, and then moving in this direction. So I'm going to use here plus and minus on the other side, because I'm going to use I2 minus I1. Somebody may ask, but can I use the same thing that you did here? Yes, you can, of course. If you want to keep it, go ahead, keep it. Okay, I'm going to keep it. You have 10 voltage, you're going there. This is minus plus, so it's positive connected to negative will be plus. Plus 10 ohm, I1 minus I2. I'm using the same thing I did here. Move. Okay. Now 6 and I2. Now will you say, why I2? Because you assume that the loop current here is I2. So it's moving I2 here. We said that it is I1 here, so we understand that it's I1 minus 2. But when you move I2 like that, so I2 is in this resistance, and I2 in this resistance. So the only resistance that it will not have only I2 by itself, but will have another current. This one common between two circuits. So when you have any resistance common between two mesh, so the resultant current will be 1 minus 1 all the time. But when you look at 6 ohm, there is no common mesh with it. It's the only this mesh I2. So I2 will be in the same direction as we assume in 6 ohm. So the positive connected to the positive, that will be minus 6 ohm times I2. Continue. I2 will make plus and minus here, and also I2 in this. So it will be plus and plus, you have minus, and 4 ohm and multiplied by I2 is equal 0. Now just let's simplify. 10 plus 10 I1 minus 10 I2 minus 6 I2 minus 4 I2 is equal 0. I1 you have 10 I1, that's it. 10 I1. For I2 you got minus 10 minus 6 minus 4. So you have minus 20. I2 and 10 equals 0. So let's just rearrange the equation. You have 10 I1 minus 20 I2 equal to minus 10. So that will be your second equation. So you got two equations of Kirchhoff voltage by using Kirchhoff voltage law. It's required to solve this equation for I1 and I2. You just can go ahead and solve it. All right. Let me just write in a piece of paper and then make it on the second page and show you how to solve these two equations. It'll be easy simultaneously. 15 I1 minus 10 I2 equal 5. 10 I1 minus 20 I2 is equal minus 10. There are many ways you can solve it. I will write them again. 15 I1 minus 10 I2 is equal 5. That was question number 1. Question number 2, 10 I1 minus 20 I2 is equal minus 10. You solve these two equations simultaneously. But what happens if you have many equations, like 3 or 4 or 5? You can use matrix or Cramer's rule as I told you before. If you do in matrix, that's the first variable I1, I2. So you have 15 multiplied by I1 minus 10 multiplied by I2, 5 here. 10 I1 minus 20 I2, you have minus 10 here. So this is the way that you are going to do it and solve it. Okay, all right. Oh, I got to give you the answer. Okay, to check your answer, I solve this equation. I1 equal 1 ampere and I2 is equal 1 ampere. So go ahead and check. You can use calculator also, solving two equations to unknown. Okay, now we're going to take two cases, because not all the time it's nice like that you have voltage source. Sometimes you can find current source. So what you will do when you have current source, I will show you now. The first one, you have here current, you have here one current source and voltage source. But the problem with the mesh analysis, that when you have current source, what we'll do here, let's just assume I1 and I2 as we do. Okay, now when you write the equation for Kirchhoff, and by the way, all clockwise direction, the first thing you do, Kirchhoff voltage law. If you go for mesh 1, write Kirchhoff voltage law, you have I1 will be going in this direction, make a plus or minus, and plus or minus, but this one is not I1 only, it'll be I1 minus I2, right? Okay, so I will just make it clear here. I know the second time I say it, but I mean just because it's a new concept for you, because you have I1 in this direction and I2. So I1 will going this and I2 going from the down up. So if you are choosing this direction, because they make plus and minus, so the current will be I1 minus I2. Now, 10 voltage plus connect to plus be minus 4 ohm time, what's the current here? I1, because the loop I1. And in this one, plus connected to plus or positive connected to positive, so be minus 6 ohm. I1 minus I2 is equal 0. But there is something interesting. You see, what is the value of I2? I2 is good, and this 5 ampere. So actually I2 is equal minus 5 ampere. So you don't have to solve for two mesh. You only have to solve for one, because the other one that has current source already give you the value. I know the value. So I will write here 10 minus 4 I1 minus 6 I1 minus I2, and I2 is equal minus 5, so it would be plus 5 equal 0. Now we have only one equation, 10 minus 4 I1 minus 6 I1 minus 30 equals 0, minus 4 1 minus 6 1 minus 10 I1, 10 minus 30 equal minus 20 equals 0, minus 10 I1 is equal 20. So I1 is equal minus 2 ampere. And you are done. You don't need to solve this for I2. I2 is equal minus 5. Okay? Okay, so it's done. Easy. So actually when you have current source, it's not big deal. It's just one equation is solved for you already, and use it. So when we have current source in any mesh, and you have like 4 nodes, and you have one current source, you are not going to, you have 4 meshes, it means you are not going to write 4 equations, you are going to write 3, because the one that has current source, it will be eliminated, because already it's solved. Okay. Now I'm going to explain another case. You remember last time, in the last lecture, we explained something called super node. Now we have a super mesh on the other hand. What's super mesh? Okay, Super mesh, when you have the definition, when you have two meshes have current source in common. In common. So inside this one that you cannot see, I mean, I'm going to show you exactly what's inside. Inside here, that there was a resistor and current source. So there was a current source here, a current source, and the two meshes here, this mesh here and this mesh here, they have a common one. Last example that we solved, this is a normal current source. It's not common between one mesh and another. No, it's only in one mesh. So when you have the current source common between two meshes, we can call this one, okay, that's a super mesh. All right, okay. So when you have a super mesh in this case, so it means that you can use it to solve it easily. Now I made it clear. We want to solve this example to find I1 and I2. So, do we have super mesh? Yes, we have super mesh. Why? Because, I mean, we have branch here, and this branch here has current source, and this current source, it's common between this mesh and this mesh. So I'm going just to delete this branch and consider this one big one super mesh. How you do that? Okay, if you cancel this, and I will sketch the circuit now, the new circuit. I have 6 ohm, 10 ohm, 4 ohm, voltage source, 20 volt. You had I1, keep I1, keep I2, but the branch in the middle, which is common, delete it. And then what you're supposed to do? Write Kirchhoff voltage law for the super mesh. How we do that? Okay, 20 volt, and then this is a plus. If I1 in this direction, going in this direction I1, it will make positive and negative. Positive connect to positive V minus. 6 ohm multiplied by the current I1. Continue. Here is I2. It's going through here I2, not I1. So plus and minus. So positive connected to positive V minus. 10 times the current here I2. There is no relation between I1 and I2. We just cancel this one, but no relation. You don't say this I1 and I2. In super mesh, the currents will be different. Continue, plus and minus. This is also here I2. So be minus 4 I2 is equal 0. Arrange the equation 20 minus 6 I1 only I1. I2 minus 10 and minus 4 will be minus 14. I2 is equal 0. So you have minus 6i minus 14i2 is equal to minus 20. Multiply the whole equation by negative 1 minus 1. You get this is the equation. Okay, the problem now we have one equation in two unknowns, I1 and I2. But you go here back and you will find that this branch is going to help us to find the relationship between I1 and I2. This is 6 ampere here. So this one going 6 ampere. And I1 going this, so it means I1 here. And I2 going like this, so I2 in this direction. So what do you have here in this node? What's the relation between I1, I2, and 6 ampere? I1 is input, and 6 ampere is input, and I2 is output. So the relationship I2 is equal I1 plus 6. So just substitute here. You have 6 I1 plus 14. I2 is equal I1 plus 6 equal 20. You have 6 I1 and 14 I1, that's 20 I1. And you have plus 14 times 6, you multiply, it will be equal to 64. is equal 20. All right, and then you move this one in this direction. So what do you have here? You have 20 I1, and then you got 20 minus 64, and you divide both by 20, and you get the value for I1. So that's the way that you do it. So it's very easy and very simple. I'm sorry, there's something here. That's 48 and 20, 48. Okay. Let me give you the answer. So, I mean, that's the answer. 2.8 ampere. So try to solve it by yourself, but let me just review the concept. It's very simple. When you have super mesh, this common branch, cancel it, work out the problem like one mesh, but the only difference between super mesh and any mesh that you can have two different current. Each current has different value in each side of the super mesh. That's all. Once you write the equation, then erase this one, get it back, and find the relationship between the currents and solve it. Easy. Piece of cake. Okay. That was simple. And I give you here some problems. If you understood the lecture, try to solve them and then ask me in the next lecture. Okay, great. Great. Have a good day and good luck. Bye.